Hey guys, we're here today to show you how to do rates of change. That's lesson 3.6. D-Beth probably taught you better, but we're going to try to clear some things up. Alright, going on to the second page here, we have our 3 degrees of the function. So you have your first situation, which is position. That's no derivative or no integral. So your units will be distance, so that's meters, centimeters, whatever. Velocity looks like that. That's your first derivative. That's distance over time. Velocity is also known as your slope, which is also known as your instantaneous rate of change. And then your distance over time would be like meters per second. For acceleration, that's your double derivative. So that's the derivative of the derivative. That's also the slope of the slope. So that kind of makes sense. Your units are distance divided by time squared. Alright, so the problem we're going to deal with today is that there's an Olympic-sized pool being filled with water. This is a chart for how many gallons of water are in the pool at time t equals 7. Approximately what is the rate that the water is entering the pool? Now, a couple things that you're looking at here. This says approximately right here because using a table that does not have a 7, you cannot specifically figure out exactly what 7 is going to be. So you're approximating right now what 7 is going to be, or what the rate is for 7. This is also giving you rate, and this is not a rate given. So this is a time and an amount of water, not a rate at which the water is entering the pool. So in order to find that, you have to take the time of the 2 nearest. So we're going to take 2 near it. We're going to take 8, which is above, and 6, which is below. And then you're also going to look right underneath. Right underneath, you're going to take 212 and 900. So what you're going to do with these numbers then is you're going to sit the gallons, which is how much is in the pool. So that's 2,112. You're going to subtract 900 because that's your 6. You're going to put it over 8 minus 6. So everyone see where I got the numbers there. I took 8, which is your larger number for time, minus your smaller number. Now this is so that you can get positive in the denominator. The top isn't always going to be positive because stuff can be decreasing, but you always want positive in your denominator. Subtracting both of them, you're going to get 1,212 over 2, which turns out to be 606. Now for your units, we can go back 2 slides. This slide. So if we go to this slide, units with a velocity, because it's a first derivative you're going for, you get distance over time, which is meters per second in this case, but you have distance over time. So coming back to here, you're going to have, that's your distance, gallons, it's what you're measuring, and then minutes is your time, so that's your time. So you're going to have, as an answer, 606 gallons per minute. Now, remember, going back to what I said originally, it's only an approximation because there is no number 7 on the chart. So that's all an approximation. Alright, we decided to give you a little brain break, watch a funny video of a kid belly flopping. Oh god. Yep. So back to this, we're enough of the video. Alright, so what we're going to look at now is that, now they give us an equation. So they're going to give us this equation. This is for water being added into the pool. We can be a lot more precise because there is an equation, we can be accurate with our data. So the amount of water at time t in minutes in gallons of water is Wt equals 4t cubed plus t squared. At time t equals 7, at what rate is water being added into the pool? A few key things to look at here is that we have our time, they give it to us in minutes. We have what we are measuring, which is considered our position, in gallons. Also, this is not a rate problem. So this gives us the amount of water. So this is giving us the amount of water. That means that this equation right here gives us the amount of water. There is no rate being involved. So given that we have the 3 degrees of our function, we have f of x, we have f prime of x, and then we have f double prime of x. So this equation right here is given to us. That's our f of x, that's our position problem. So that's what that is. And then moving on, so this now tells us that at time t equals 7, gives us a specific time, at what rate is water being added into the pool? So, moving on with a rate, that's going to give us our prime. So that's going to give us our velocity, and that's what we are trying to solve for right now. An easy way to find velocity is going to be taking this and taking your first derivative. Now, this is an easy one because the numbers are fairly simple. So you're going to have w prime of t equals 12 t squared plus 2t. So we could just solve in, you just add it in, so w prime of 7 equals 12 times 7 squared plus 2t. So that's pretty simple. So doing the math on this equation, you get 602 gallons per minute. So this is really interesting actually if you look at it. So using the equation, we get 602. Now if you remember back the last problem that we just did, you get 606 gallons per minute. It's an overestimation on how fast it's entering that water is entering the pool. And so this is an overestimation with the graph, and this is exact with the equation. So that's just an example of how we are approximating when we use anything but the equation. Yeah, right. So here are our graphs. So this is W of t, which means that this is our original one. So this is how much water is in the pool, or how much is in there at a given time. So this is your position. Then this is your velocity. So what you're going to do is you'd find 7, you go up, you draw the line at 7, and that point, this point will equal 602. So 602 then, coming over to your position graph, means that at this point of 7, going up right here, the slope of this line at the point of 7 is going to equal 602 gallons per minute. So that's when you bring over 602. So 602 is your value of the slope. That means that your slope here at 7 is 602 gallons per minute. That's 3/6.